Setting a developer portal properly takes weeks. Blueprints, actions, workflows, GitHub integrations, scorecards, relations between entities. It's a massive undertaking, and most teams underestimate how much work it actually is. At least if you want to do it right. Now, I wanted to set up Port, which is my favorite commercial internal developer portal. If you're building an IDP, Port sits on top of it and gives you the UI layer. Now, I covered Port in depth in the past, so I will not rehash what it does here. Watch the videos, should be somewhere there. Now, here's the situation. My Port account is completely empty. I destroyed everything so we can start fresh. I want to set up everything. Blueprints, actions, workflows, GitHub integrations, scorecards, the works, everything. But I don't have weeks. I don't even have days. I want to do it right away. Now, clicking through the web UI isn't an option, let's face it. Writing endless JSON and figuring out dozens of API calls isn't the option either. Port is awesome, but it's not magic. It's not. It doesn't just materialize results out of thin air. Or maybe it does. Now, let me show you how we'll do it. We'll start from the platform builder's perspective, then we will switch to how platform users can interact with it. Now, I created a prompt, and it's called Port Setup, and it has instructions for what I want in Port. I will show you the prompt itself later. For now, just watch what happens when I run it. Now, I will fast forward through this since the whole process takes a few minutes and we don't have that much time. You'll see the output and I'll comment on the important parts. To begin with, it discovers my environment first. It checks what GitOps tools I'm using, whether external secrets operator is installed, and what tools are available. It also calls Port's MCP to list existing blueprints and integrations. But so far, that's just reconnaissance. The real MCP action is about to start. So I told it which resources I want to track, clusters, namespaces, and my 2 custom CRDs for apps and databases. So what did it do? It created the blueprints I asked for using Port's Create Blueprint MCP tool. It deployed the Kubernetes exporter through ArgoCD and created a cluster entity with the Create Entity tool. Then it verifies that everything is synced correctly using the List Entities tool. And all that is happening through the MCP. Next, it checks existing integrations using get integration and get integration kinds with examples, and then it uses get blueprint to see which GitHub blueprints exist, and since they don't, it creates them with create blueprint tool. And now, here's something interesting. There is no MCP tool to trigger a resync, so the agent falls back to calling Port's REST API directly with CURL. It works, but it shows the MCP doesn't cover everything, at least not yet. And finally, it verifies the sync with list entities. Now, for self-service actions, it first creates GitHub workflows that will handle the actual resource creation. Then it uses Port's Create Action tool to register 6 self-service actions, create, update, and delete for both apps and databases. And each action is wired to trigger the corresponding GitHub workflow. Okay, that's the full setup. It's done, and it's all done through MCP calls. Actually, not all. Some were API calls. And here's the proof. Everything we just created through AI is now in Port, ready for platform users to interact with through the web UI or any other interface. The blueprints are there. The apps and their details are in the catalog. The databases are there as well, and so are the namespaces. Then there are GitHub workflows, workflow runs, and pull requests, and it's all synced. And the self-service actions are ready to use as well. So, how did all that happen? How was all that created? Did AI all of a sudden become very, very smart and clairvoyant? Did I write thousands of lines of detailed instructions in that prompt? Nope, no, nix, nine. Port folks understood the value they possess. All data flows into their portal and they have an extensive API. Those two, combined with taking AI seriously, resulted in agents that actually work. We can access agents from their web UI, from Slack, from N8N, and from a few other places. I could not care less about those. I'm a software engineer. I don't write code and perform operations through a web UI, nor through Slack, nor through any of those. I use terminals and IDEs, so it was natural for me to try it out from Claude Code. So what we just saw is only scratching the surface. Ports MCP has a lot more to offer. Currently 27 tools covering blueprints, entities, scorecards, actions, integrations, and a few other things. Ports MCP lets us do almost everything we would need. And the downside? Well, there are too many tools, and many have longer descriptions than they should. As a result, Ports MCP occupies a big chunk of the context window. Still, it is very impressive coverage. Now, all this was from the platform engineer perspective. Now let's switch to platform users and see how they can interact with it. Users can interact with Port through the web UI, Slack, or any other interface. But a coding agent like Claude Code or Cursor combined with Ports MCP, oh, that's a very powerful combination. Setting it up was easy. Now, let's see how beneficial it is to use it. I asked about my app status and got the info almost instantly. No clicking through UIs, no navigating dashboards, just ask and you will receive it. Now, let's try creating something. The agent found the blueprint and is guiding me through each field interactively. It's like a form in a way, but in my terminal. If I fill it out, that would execute one of the ports actions we created earlier. That action triggers a GitHub Actions workflow, which creates a manifest in the repo, and then ArgoCD syncs it to the cluster, and all the shenanigans are happening over there. It does not matter from the user perspective. Hey, I want application or database, I get it, after I answer a few questions. Now, that whole chain we just saw was set up earlier. That was that first and single prompt I executed, and then it worked for a few minutes, and then we got all that. And a few other things I'm not showing here. So, from the user's perspective, Port is, hey, at least the MCP part or AI part is just ask to create a database and answer a few questions, and you just watch the magic happen. So, how did all this work so well? Now, it wasn't only the MCP. I had to write a few lines in a prompt. So here's the prompt I wrote for the Port setup. So what's the main gist of it? Use Port MCP to explore what's available and act accordingly. That's the whole prompt. The MCP handles both discovery and operations. I mean, not only MCP and my agent. It was a relatively small effort on my part. The real glory goes to the MCP, to Ports MCP. So here's the takeaway. Capable models and coding agents need the right context to produce good results. We saw that in the simple prompt I wrote, but even more in all the context Port MCP provided. Give an LLM the right context and it can instruct the agent to do the right thing. The end result is, it's really impressive. I got almost everything I needed, and it was almost 100% correct. Not perfect, but close. All in all, I think that Port really gets it. They understand how to combine AI the right way with their product, which was already built in a way that makes it easy to put AI on top. It's been a while since I've been this impressed with a non-AI company adopting AI this well. Port was awesome before, and now it's bloody amazing. Now, that said, there are a few issues I hope Port will address soon. Those don't make it bad, it's not really a disaster, but fixing them would make it even better. To begin with, Port's MCP has no intelligence. There is no agent with a proper system prompt or dynamic context, so getting good results requires understanding Port well enough to write effective prompts. I could do it because I know Port. A newcomer would struggle. If Port added that intelligence layer, even newbies could get great results almost instantly, out of the box. Next, the context size of Port MCP tools is just too big. It's massive. Now, there's no auto-discovery. You have to manually create blueprints for Kubernetes resources beyond the few baked in and manually define relationships. I mean, when I say manually, AI did that, but their agents should be so much better. It would be so great if Port would dynamically discover all those by examining, let's say, owner references. Then there are missing tools in the MCP, like update integration, for example. Now, fortunately, AI can fall back to Port's API, and it can get information about the API from the MCP, so it's not really that bad. Now we come to custom prompts that are served through the MCP, and that's such a great idea. However, I did not show it in the demo because I feel that Port went the wrong way with prompts. We need to create blueprints and actions and GitHub actions and what's not. AI gets easily confused. It's complicated for no good reason. Actually, the reason is obvious. Port tried to fit prompts into their existing data model, so we have Markdown that is transformed through GitHub actions to Port's JSON format, only to be transformed later on again inside the MCP. It's over-engineered mainly to fit Port's data model rather than thinking, hey, what is the best user experience and the easiest way to do it? It's a good idea with bad execution, mainly because Port chose to stick prompts into their existing model. A good design would be, hey, here's my Git repo with prompts, serve them as they are. If prompts would be working well, I wouldn't be running it locally. I would have it in Port as well. There's a custom prompt. And now comes the good parts, the cool parts, right? Pros. First of all, Port's data lake or context lake or whatever they call it acts as a single source of truth for everything. Knowledge base, operations, all of it. And that's absolutely awesome. It's amazing, really. Giving all the information to AI through MCP is what is needed, really. That's the bulk of the work. The second amazing thing is Port's API investment, which paid off. I doubt that many were using it directly until now that agents are using it through the MCP. I just wish all API endpoints were available through the MCP. They hopefully will be soon, I hope. Then we have the fact that API is dynamic. It is adapting based on blueprints and actions and whatever is configured in Port. So you don't get some generic MCP. You get dynamic MCP server that understands your account, your data, and so on and so forth. Finally, the addition of custom prompts served through the MCP is a nice cherry on top of an already delicious cake. We can add our own prompts that will be served through Port's MCP. That solves two problems. To begin with, there is no need to worry about each agent expecting prompts in a different directory. And then there is distribution, which makes it easy to have those prompts in any project. You just connect MCP, you have it. Nevertheless, while the idea is good, the execution isn't. So this feature is both pros and cons. It's a good feature with bad design. Overall, I'm really impressed. I'm not often impressed, but now I'm impressed. But I see one big gap in Port's approach, apart from those I already mentioned. The context lake or content lake or whatever, data lake, whatever it's called, it's great. It contains all the data ingested into Port, and now all that data is accessible to AI. But that's only a fraction of the data that matters. Much more detailed and more valuable data sits in Kubernetes, in AWS, in GCP, in Azure, in GitHub, and elsewhere. It would be insane to ingest all that into Port. Kubernetes alone would be too much. Hyperscalers would ground it to a halt. But here it goes. What if Port gave hints to agents? It knows where data comes from, and it could provide that info to agents with additional instructions. Imagine the MCP returning something like, hey, check this Kubernetes cluster and those resources for more info, or look at this AWS account for details. Agents like Claude Code or Cursor could then connect the data and provide much more accurate information. Connecting Port's context lake with actual runtime data would be a winner. That would be amazing. I don't understand why Port didn't do it. If Port did do that, if it connected the dots, it would not just be a portal for simple observability and operations as it is now. It would be a portal to everything. That would give AI superpowers way beyond what it can do now. Overall, if you're building an IDP and you need a portal, give Port a try. And if you're already using Port, connect the MCP to your coding agent. It takes only a few minutes. Now, it could be better, it could be much better, but when compared with other solutions, it's awesome. Thank you for watching. See you in the next one. Cheers.